So cool guys. So in this session we will be discussing the Codeforces round 859 that was rated for Dev 4. We'll be going over the problem E and F. So the problem E is called interview. The problem states that before the last stage of an exam, the director conducted an interview. He gave gone n piles of stone. The ith pile has exactly AI stones, and each pile is identical and weighs 1 gram. Right? Each stone is identical and weighs 1 gram except for one special stone that is part of an unknown pile. Right? So there would be one special stone in this pile that is not known to you prior hand, right? You have to predict which pile is that which has this special stone. Now the unique quality of this stone is that it weighs twice as much, or you can say it weighs 2 grams. Now they'll be providing you with the piles and the number of stones in it. So they'll be saying that you have 5 piles and these are stones in it. Now this is an interactive problem. So what do you mean by interactive problem is that they'll not be providing you with the exact weight of the stones. That is something you have to guess, right? So how can you guess it? So you'll be asking the computer, or you'll be asking the OJ or the online judge, right? That tell me what is the weight of these number of stones. So you can say that okay, I want to know what is the weight. Okay, let's say this example over here. So you'll say I want to know the weight of the piles, the first pile, the maybe fourth pile, and maybe the last pile, right? So it's gonna tell you the weight, and using that kind of a thing, you'll have to predict it at the end. So if you are solving this particular problem, I am assuming that, or if you're trying to solve E, I'm assuming that you are already familiar with binary search. If you are not, then I hope, or I'll expect you to watch some videos on binary search first, right? Okay, so for what we can do is that we can say that, okay, I'll just explain that on my iPad. Give me a second. Cool. So let's say these are the stones, right? These are the piles of the stones that I have. Now this has some stone, right? This has some stone, this has some stone, this has some stone, right? And this has a special stone. Now when they give me the piles, right? So initially they gave me the piles that okay, this had 2 stones, this had 3 stones, this had 4 stones, and this had 3 stones, right? Let's say this is what is given to me initially. So I know that in ideal case wherein no stone is special, so their weight would be, this would weigh 2, right? This would weigh 3, this would weigh 4, this would weigh 3 itself. Now if I make a pre-sum matrix out of it, so I can say that this like I'll be summing from left to right. So 2, 5, then 5 plus 4 is 9, then 9 plus 3 is 12, right? Now I'll ask my online judge that tell me what's the weight of these 2 piles, right? Let's say for the pile 2 and 3, or for the pile, sorry, 1 and 2. So it'll say that okay, so the weight for the pile is 1 and 2 is 2 plus 5, or so, not 2 plus 5, but 2 plus 3, that is 5. Right? Now you'll say that okay, I was also wondering that up to this only 5 should have been the weight. So that is technically correct, right? So definitely the stone which is special needs to be to the right side. So that is something we'll know when we do it in this fashion, right? Then maybe you ask it that okay, what is the weight of the piles for 1, 2, 3 and 4, right? So you'll ask what's the weight of the pile 1, 2, 3 and 4. So that is 2 plus 3 plus 4 plus 3, right? But over here one is a special stone over here, so this actually weighs 2 grams. So pile of the weight 3 is actually 5 grams, although you were thinking that it's going to be 4 grams, but in actuality it's 5 grams, right? So when it'll sum up, so it'll say that the total weight up to fourth pile is 2 plus 3 is 5 plus 5 is 10 plus 3 is 13, right? So it'll say that the weight of these 4 piles is actually 13. Now I will say okay, cool, so that means I was assuming that the weight has to be 12, but since you are saying 13, then either this pile would be corrupt, right, or this pile would be the pile which is having the bad weight, or some pile to its left. That definitely makes sense, right? Because I'm considering all the piles in this particular area. So either this is corrupt or some pile to its left. So I'll set my result point to this particular index, that is the fourth. And then I'll say I want to check the remaining, or I want to check that if it's the case that a pile just to the left of me or to my left is valid or not, right? So I'll place a midpointer over here, right? And then I'll test the same. Now this becomes a standard question of binary search. So that's what we are gonna do over here. Now the approach is pretty simple, but my main idea over here would be to teach you how to solve interactive problems. So if I go to the code, even I was trying a lot of different ways so that to rule out that what all are the scenarios wherein you'll get a wrong answer or you'll get an idleness limit. So okay, so this is the standard boilerplate code, which I guess all of you in Discord would know because we already had a video on or already had a session on binary search. So what this code does is, okay, so this is something I wanted to tell you. So most of a lot of times we want to make a Prism matrix, right, or a Prism vector. So we have to manually make it. This is a better way of making a Prism matrix, right? So you make a matrix, initialize it to 0, and then you pass the first or you pass the iterator to the first element of the array for which you are calculating the Prism matrix. Then you pass the last iterator of the array for which you want the Prism matrix, and then you pass the beginning of the array in which you want to store this Prism, right? And the function's name is partial sum. So it makes the Prism matrix on its own. Now it's far better than writing like maybe 5-6 lines of code, and it's more intuitive, more easy, and more understandable. After that, this is the standard BS code or the binary search code. So over here, the thing that you need to notice is that when you will be asking your system that, okay, tell me that what is the weight of these all elements. So that statement needs to begin with a question mark, right? So you'll say question mark followed by how many elements are you gonna ask me for. So I'm gonna ask it for mid elements, and what are the elements for which I want the system to give me the weights. So I want the weights from 1 to mid elements, right? So I'll be printing the indices, or yeah, I'll be printing the indices of the piles for which I want to know the weights, right? After that, flush is also a useful statement over here. If you're not using flush, right, so the output you are producing actually just remains in the buffer itself. It doesn't get flushed onto the screen. So in that kind of a scenario, your system actually doesn't know that you have already printed out something. Okay. So after that, we'll flush it so that the buffer is already flushed onto the screen, and the computer system knows that we have already printed out some values. So over here, when we print out this, then the system would know that, okay, we are expecting some values, right? And we have to accept that value as well. So the system is going to give us some value that would be the weight of all these piles. We're going to store that in the variable val, right? And then I'm going to do the checking. So if the value up to this point, right, if it's less than the value that the system returned me, right, so that means that my answer is the pile that contains the special stone is in some index from 0 to this particular index, right? So I'll do that. Else it is present in some right pile. So I'll do low is equal to mid plus 1. At the end, once you quit this loop, so you will be sure that you have the answer in the variable res. So how do you print it? So all of the time when they'll be asking you interactive problem, this is something they'll specify, and most of the time it's going to be the same kind of a scenario. So whenever you're gonna ask the system, right, to provide you with some values, you're gonna start the line with a question mark. So I think, yeah, over here. So whenever you are gonna ask the system for some values, right, or some query, you'll start it with question mark followed by the number of files you wanted to tell you the weight for. And when you're printing the answer over there, you need to start your answer with the exclamation mark. Yeah. So when you have the answer, you start with the exclamation mark. So that's the general way of doing stuff. But still, don't take this for granted, because sometimes it might happen that they actually change it by a bit, or they change the format by a bit. So always read this carefully and proceed like in correspondence to that. This makes sense? Any doubts? Any doubts, or you can turn off your mic maybe. Okay, cool. So let's move ahead to problem F, right? So problem F is a bouncy is called bouncy balls. Now this is a very easy problem, doesn't require any complicated DSC or stuff. The only thing is it's an implementation problem, and if you get into that weird habit of using a lot of if-else statement, the code might get a lot complicated, right? Now I personally know that Harsh would have been able to do this problem, but the only point is that he got confused. So this problem is not tough per se, it's a simple implementation problem, right? Now I'll try to teach you how to do implementation problems when the code is a bit bigger and there are supposed to be a lot of if-else statements. So let's go through the problem once. So the problem states that you are given a room that can be represented by n into m grid. there is a ball at the position ij, the intersection of the row I and j, that's obvious, right? And the ball is going down and right, denoted by dr. So there could be four movements, right? We are gonna travel in diagonals for sure. So either you can be going down and right, you so okay, so this is down and right, correct? And this is down and left, this is up and left, this is up and right. So these are the only four movements your ball can actually be in, right? So let's say if this is a room, your ball would always keep moving, and what it will do is that it will go to a place, then it will bounce back, right? So it will keep dodging. Now one important thing to notice is that it's not like the pattern actually would get completed once it traverses the same row back. What do I mean by that now? Okay, so what would happen over here is that let's say a ball is here. Now it came over here, then it came over here, then here, then here. Now it traverses back, right? As soon as it comes back, you'll know that it's going back in the same direction. So you can say that, okay, the pattern is already complete. It will keep following this particular pattern till eternity. No matter how long the game runs, it will always keep running in this particular fashion. So that is the first observation. Now, it is possible that my ball goes from the position 1 3 to 5 7, right? And the value I'm trying to calculate is, let's say, 2 4. And that actually is the right test case also. But yeah, this is a good test case, right? So what would happen is that I only can calculate that, okay, 1 3 would be my starting position, and 2 7 5 7 would be my ending position. Now 2 4 lies in between the path. So at this point, the circuit would complete, or I'll say that, okay, I'm able to like reach to my final destination. But how would I like code it up, right? So that is first thing. So let's try to understand the variables or the kind of function that we are going to use over here. Okay, give me a second. Okay, so the first thing would be that, okay, this is your matrix, right? Now when your ball is rushing from any point to any point, so first thing you want to know is that if I provide you with the start point, right? So by start point, I mean that the point from where it starts traveling, right? Start point. And I provide you with the end point where it's gonna hit, right? You should provide me whether the ball would actually go over the point I'm willing to travel, or which is the final destination. So this should be a function that should tell me that would I travel across my destination. So there should be such function. This can easily return you boolean, right? Now the only reason for making function is that modularity actually makes your code more simpler. It makes it easier for you to read as well. And in case you are like committing some mistakes, then it's easy to detect and easy to change. So there are actually a lot of benefits. Yeah, it's obvious that it's gonna take maybe a couple of seconds more to code it up, but it's always worth it. Cool. What would be the second thing? So over here, I said that the endpoint needs to be known, right? So how would you calculate the endpoint? So let's say that also is a function. We'll worry about that later. Now I'm just talking about the black box view right now. So this is just the black box view that you know what you are going to pass to it, and you know that what it should return you. The implementation we can worry about later. And the second function would be a function that would tell you that, oh, you will tell you two things. So what's your start point? That always you will be knowing, right? So start point you will be knowing. You will tell it the direction, right? And then what it should tell you is, okay, so it should tell you what's the end point, right? And what would be the new direction. So as soon as you reach an end point, there would be a new direction, right? So for example, over here, so you were going in down and left, right? So you were going down left. As soon as you hit this particular point, you started traversing up left. So this function that I'm creating, or the second function, should return me two values. The one is that what is the point where you'll hit. So it will return me that, okay, if you're starting from 1 7, you're gonna hit. If you're starting from 1 7 with the direction of down and left, then you're gonna hit 5 and 3, and your new direction is going to be up and left, right? So let's just write that. So okay, so this will tell you the starting point. This will tell you the direction. So initially the direction, let's say, was down and left. So as soon as it should return me up and left, depending on the endpoints. Now let's start understanding. So this thing is clear. If I have these two things, I can easily write my code, right? So our first set of things is done. We are able to delegate it further to our functions. Now so currently we only have a black box view, right? Let's try to understand how these functions would work. Or that would be even simpler if I just showed you the code, because code is also actually simple for this. Okay. So this is the function. Yeah, this is the function that is the second function I was talking about. So this would tell you two things. It will give you two integers that would be the x and y values of the point that you'll hit at, right? And it will tell you the string. Now the string would actually be the direction at which you'll start traversing. Cool. So with that, let's start with the function or the implementation. Now what would I'll firstly assume that I'm gonna go in a direction wherein my x coordinate and my y coordinate is gonna increase, right? So x coordinate, y coordinate technically increases when you are going down and right, right? Okay, down and right. Okay, because if you are going down, then your x increases. If you are going right, so this is down, your x increases in down, and this is your right, your y increases in right. Okay, now I'll see that I have already assumed that you are going down, but if you are going up, right, then make your dx -1 because you are going to decrease your x coordinate with each move, right? And if you are going left, then I initially assumed that you are going right, so decrement your y at each move. That's also obvious. Then what I'll do is that I'll say that I want to know what are the number of steps it's going to take you to hit the boundary. Now what do I mean by that? Okay, so let's say this is the point you're at. I'm drawing a xy axis. I know this is wrong because technically a room is like this, but just bear with me for a moment so that I'm able to explain this well. So let's say this is the point you're at. Cool. And you're traveling in this manner. So initially you'll be going over here, right? And then you'll hit this. So the place at which you hit this particular axis is this, right? So there's this point and then there's this point. Now, since let's say this distance was A, right? And this distance was B. I just need to find out if A is greater or B is greater. If A is greater, then B is gonna come soon, right? Because if A is greater, it definitely would hit it over here. But since it was a closed room and it was bounded like this, right? So it would have hit over this point, let's call P, and it would have bounced back. So in order to check that, I can easily say that if A is greater or if B is greater, whichever is smaller, that would get hit first. So that should do the trick, right? So that's exactly what I'm gonna check. So I'll say, okay, so over here, once I've marked my dx and dy, I'll say if my dx is negative. Now that means that I'm gonna decrement my x every time. So I'll be going like, I'll be at x currently, then I'll be going for x -1, then x -2, then x -3, so on till the time I reach till the time I reach 1. So how many steps do I need to go in this direction? That is basically x -1. If my x is positive, then I'll be going from x +1. Okay, so I'll be going from x to x +1, so on till the time I reach n. So the number of steps over there are n minus x. Similarly, the case would be for y, right? I need not explain that. Now, if my steps are equal, now when would that happen? That my steps are equal. That would exactly happen. Like, wait a second. Let me rub it. Okay, cool. So that would exactly happen when your position is such that your A and B are same, right? So if your A and B are same, you're exactly gonna hit at this particular point, right? So what's special about this? The only special thing is that the way your coordinate would actually change. So if at this particular point you were having a direction down and left, that's exactly what you're having, right? So if you're having down and left, it's going to bounce back in the same direction, or in the opposite direction, it's going to become a upright. If you were bouncing it over here, then in that case, your direction would have changed to upright, up and left only, because left wouldn't change. It would keep moving over here. This is the up direction. Okay, let me change the color. Yeah, this is actually the up direction, but it is also left. So the thing we are able to understand is that the point it reaches first. So if it's reaching this particular axis first, then only the like up would reverse, or the like upward direction and downward directions would reverse themselves. Left and right doesn't change. If we try to hit this kind of a point that is on this particular axis, right, then up and down wouldn't change, they would remain the same, but your left would become right and your right would become left. Cool. Over here both the points change. This point is clear, because this was the major thing to understand over here. Is this point clear? Okay, cool. I'll be moving ahead then. Cool. So once you're done with that, you'll say if the points were equal, then you try to get to the head. Now your points were equal, so you can say from x you'll be traveling steps I point, right, in this particular direction. So the final point would be x plus steps I of dx, right, and in y this would be the point you'll be hitting, and the answer or the new direction, for that you'll be reversing both the pairs. So you'll be reversing whether you are having up or down, and then you'll be reversing whether you're having left or right. But if let's say your steps I were greater than steps j, in that case you'll be hitting the uh, axis of the jth element first, or you'll be hitting the y-axis first, right? In that case, what you'll do is that you'll say that okay, steps j is less, so I can move only this many steps. At this point, I'll halt, or I'll bounce back. So yeah, x plus steps j into dx plus y into steps j into dy. Now your x or the direction along x is not going to change. Your direction along y is only going to change, as I explained earlier. So you'll do that. The last case is when your steps I is going to be less than steps j. So exactly opposite of this is going to happen, right? That is also simple to understand, I guess. Cool. With that, we reach over here, right, in our code. But wait, there was one more function that we utilized. We wanted also to know that whether the point or the end point that we want to traverse is going to lie in our journey or not. So to do that, what I'll say is that my dx and dy would be set in the similar fashion like I said over here. So that I already explained. I won't be explaining that. Then you'll say that like the point that you want to traverse, right, is that in a positive direction or is that in a negative direction, right? So if your direction x, right, if you say over here that from x I need some positive distance to go for my ei or the endpoint. So distance you need to cover to ei, right? So if it's some positive distance, or if it's a negative distance along with the magnitude that gets stored over here. Now you'll say if the distance is actually 0, then that means you're currently standing at this particular point and you already got it. Cool, I'll return 1 in that case. But now, if your distance is positive and your dx is negative, right? So in that case, you won't be able to do that. Or if your distance is negative and your dx is positive, also in that case, you won't be able to do that. So these are two cases. So either if this is 1 and this is 0, or this is 0 and this is 1, in either of case, you won't be able to do it. The same would happen with the y as well. So you coded that up. Now, if all of this statement weren't hit, then the only scenario is that your absolute difference between the x-axis and the y-axis need to be same, because at each point you're only going ahead by 1 unit in both direction, right? So you will either be traveling, let's say, +1 or -1. Right? So the absolute values of direction x and direction y needs to be same. So that's it about the two functions. Now let's see how do we use them in our function or in our code. So firstly, we take the input from the user. I'll not be explaining that obviously. Then this is the visited set I have made. So this is just to know that I have like if I have found a pattern or a loops. Let's call it loops. I can remove this. This wasn't being used. Then I'll keep continuing this. So this is an infinite loop I'm running. Now I'm saying that if the current direction along with the pairs is something I've already gone through earlier, that means I already directed that point, right? So in that case, return -1 because you are now in a loop, and in this entire loop you were not able to come across any point, right? Wherein you were not able to come across the point you wanted as your final destination. If that's not the case, let's insert it. Cool, you'll be inserting it. Now you'll say that if from this particular positions, right, if you are able to visit these two points, if you're able to visit these 2 points from this position, Then let's declare that you already got the answer and let's return the number of bounces. Else what you'll do is that you need to like update the values now, because now you'll be going from a point A to, let's say, B, right? So you need to update the values. That is being done by get rebound get rebound point. That function I've already discussed. At the end, after setting these values, you'll be incrementing the value of your bounces. Cool guys, so that's it for the solution.